Good day, my name is Dinesharajan Naidu, and today I'll be explaining about the binary search tree program that I have created. And later on, two of my group mates, these two right here, will be explaining about two different sort programs. So let's start, shall we? Now, the first thing is we're going to take a look at is the header file for the binary search tree that I have used is iostream, and this is the node used to create the binary search tree basically. And yeah, as you can see here, there is the data. This is to keep the data, and these pointers to point to the left node and the right node. And these are the prototypes for each function used except the main function, and that does not require a prototype. So, and these are pointers because the inside is we are going to reuse the point. We are going to re-declare the function in the program. So that's why we're using a pointer right here. And void is not going to return any value. So let's start. Create node is to create a new node for each node. If let's say the root is now, we will use this function right here to create a new node, and the data will be inserted into the node, and their left pointer and right pointer will be null, and it will return the new node, and the new node will be assigned to the root. And this is the insert data function, which will insert the data given to the inside the new node. So yeah, it will take root and integer data. The data will be integer as this is a binary search tree. And if the root is null, it will create a new node using this function above. And once it has returned a new node, it will check if the data is more than the root data. If the data is more than the root data, it will create a new node to the left. If the root data is less than the new data, it will create a node to the right, as you can see right here. And next is the traversals for the binary search tree. So this is the pre-order traversal. It will display the binary search tree in pre-order. This will display the binary search tree in order, and this will display the binary search tree in post order. And this is the main function where we will get the number of values from the user. As you can see here, this is the number of values needed to be inserted into the binary search tree by the user. And the first value will be the root value, the root node value. And yeah, this for loop right here is to just repeat the statement. Please enter. This is to repeat the number to input the values based on the number of values. So let's say you've entered 5 values. This will iterate 5 times, and it will insert each value into the each value into the binary search tree by calling the insert data function. And lastly, this is to display each traversals. So let's take a look. I'm going to run the code, and first we're going to enter 5. We are just going to enter 5 values, and let's take number 10 as our root value. Then next we're going to use this is for the rest of the nodes in the binary search tree. So 7, 4, 12, 15, and that's it. So this is the code for the binary search tree. Next off, my two other teammates will be presenting two different sort programs.
Good morning, sir. I'm Sir ZIXIN from class DDT M3. My matrix number is 01 DDT 20F111. This is the coding of selection sort. So first, we declare array size as 5. Then we ask the user to enter 5 integers. Let's say 30, 20, 50, 10, and 40. Then display unsorted array. We display the numbers we entered just now. In order to display sorted array, we use the function selection sort. This function calls the function header. So this is the numbers we entered just now. In the first looping, set index 0 as I equals to min. In the second looping, I plus 1 equals to j, index 0 plus 1 equals to index 1, j equals to index 1. If 20 is smaller than 30, then j equals to min. Then j increment becomes index 2. 50 is not smaller than 30, so j does not equals to min. J increment again. If 10 is smaller than 20, then j equals to min. Now j increment again becomes index 4. 40 is not smaller than 10, so j does not equals to min. If min is not equals to I, then perform swapping. So swap I and min. Now the order of array is 10, 20, 50, 30, and 40. Go back to the first looping. I increment. I equals to index 1. I equals to min. Repeat the process for index 1, index 2, index 3, and index 4. This is the final order of array. The output of sorted array is 10, 20, 30, 40, and 50. Now we run the code. Input 30, 20, 50, 10, and 40. The output of sorted array is 10, 20, 30, 40, and 50, sync to the result of selection sort. That's all from me. Thank you.
Bubble sort data structure C++ program. At here, the program declares the size of the array is 100, and next, this code displays the output to us for user size with maximum of 100 elements. Then, after the user input the size, the program will check if user size is greater than the program size. And if it is greater than the program size, the program will notify the user and ask the user to input the element size again. Next, the program will display output to ask user to input all the value of the elements in unsorted order. Then, after the user input all the value of all the elements, the program will start to sort the element by bubble sort method, and finally, the program will display the sorted order of the elements to the user.